All right, guys, we're going to start looking at some trigonometric graphs today, just introduce you to them, and we'll go further and further with them. But today, just an introduction to what the trig graphs look like for sine and cosine, just sine and cosine today. Sine and cosine are both called periodic functions because they have a period or a cycle to where they begin repeating. Both of their periods are 2 pi. After every 2 pi that you go, their values start repeating themselves. Think back to the values we did earlier, like we had, let's say pi over 3 right here. Pi over 3 gave you the coordinates of 1/2 and square root of 3 over 2. Right? If I went all the way around and back there and became 7 pi over 3, same thing. Okay, so basically what happens, I just went 2 pi. Every time you go 2 pi, the values begin repeating themselves. So that's important when we start doing our graphs. The graphs are going to start repeating themselves after every 2 pi. 2 pi. All right. I'm going to show you the basic one here, just y equals sine t. And what I did is I actually took a picture of a chart that had all the values that we know, like 0, pi over 6, pi over 3, pi over 2, pi, all the way till I got to 2 pi. Okay? And this was the sine values of those numbers. But basically an XY table, which I did right there. And I graphed it using the XY table, and the graph looked just like this. Okay? Now the red part you see, this right here, that period where it says period 2 pi, that's the part from the table. Okay, if you notice, it started at 0, it went up, down at pi, back at 0, because look at 0, 0 and pi. Back to 2 pi, look at 2 pi is 0 again. And then what happens is the values start repeating. So that graph right here, this basic graph right there of sine is going to repeat every 2 pi. Both directions, every 2 pi. These should have arrows on the end because it just keeps on going. It goes forever. Notice it goes up to 1 and down to -1 because look at the largest numbers. The largest number and smallest number in that table are 1 and -1. Some people, you may look at that and think, well, that's bigger. It's really not. Square root of 3 is less than 2, so that number is less than 1. So that's what the sine graph looks like. Again, starts at 0, goes up, stops at 2 pi, then starts to cycle over again. Did the same thing for cosine. Made an XY table again. This time the cosine values are down here. Did the same thing, plotted them. Here's the part between 0 and 2 pi. The only difference is cosine of 0 is 1 instead of 0 like sine was. So it starts up here. And the pattern goes, it kind of goes down, back up. And guys, then when it gets to 2 pi, it's back at 1 again. And what happens is it starts again, down, up, and every 2 pi it repeats. So 2 pi is a period, and there's a horizontal stretch or shrink, if you know what I'm saying. Okay, let's try a couple. The rules for transformations also work with trig graphs. So this one says, it's supposed to say f of x equals 2 plus cosine x. Okay, so watch what I do here. If I'm going to graph this one, cosine x, we're going to freehand all these tomorrow, and I'm going to go 2 pi, 1 pi, I'll go 4 slashes every time. Remember, that's 1, that's -1. So the cosine, I'm going to do this real lightly. The cosine graph starts it up here, and it goes down, up to right there. And then, it starts again. It'll start, I'll change colors again. I'm going to keep changing colors on you. It starts doing this over here. It starts doing this because it keeps repeating. But this 2, don't forget what the number on the outside does. The number on the outside shifts it up or down exactly like you think. So what's going to happen is that graph I just drew is going to get shifted up 2 units. So the cosine graph, every point I just drew is going to be shifted up 2. And what I should have done when I did that graph, I should have made there's a point there, a point down here, a point there, a point up there. I'm going to shift those all up to there, 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 there. So if I shift the cosine graph up by 2, it looks like this. And of course, it keeps going, it keeps going. That's cosine shifted up 2, like you've done before. Let's look at the second one. The second one here says g of x is negative cosine x. Remember, negative in the front reflects across the x. Negative in the front reflects across the x. So the basic cosine graph, again, 1, -1, I'm going 1, 2, 3, 4. The basic cosine graph, that's 2 pi, that's 1 pi. Starts at 1 and goes down and back up. So the basic cosine graph, again, looks like this right here. And of course, it keeps going, keeps going. Now, this has got a negative in the front. So what happens there is every point gets reflected. So that positive 1 up there gets reflected to -1. That 0 can't get reflected. The -1 down here gets reflected to positive 1 up there. That one can't get reflected. The -1 up there reflected. So instead of going down, up. The reflection is going to go down, and it's going to keep going like that. So the blue one right there, the blue one is what happens when you have a negative in the front. It gets reflected across the x, just like we've always done. All right, 2 more words, and we're pretty much done. The next word is amplitude. Amplitude is basically how high and how low your graph go from the middle of the graph. Okay, this one says find the amplitude of y equals -3 cosine x. Okay, notice the 3 in the front, we used to call that a vertical stretch. The word for vertical stretch with trig is amplitude. That's the only difference. So what's going to happen here is instead of going up to 1 and down to -1, I'm going to go up to 3 and down to -3. I'm going to go just a little further this time. All right, so I'm going to go up to 3, but there's a negative in the front, which means it's been reflected. So usually I would go up here. I start like, I don't know if you see my blue dot right there. I start up there, but because it's been reflected, I'm going to start at -3. It's going to come up. It's going to come up. It's going to go back down because it's cosine. Up, up, down, down. So the graph, the basic cosine graph will look like that. Remember, it keeps going. And you could also keep it going on this side. And it would keep going. Right? And that's all it is. Amplitude, the number in the front, the vertical stretch or shrink, how far up and down you go from the middle. If you look, here's the midline of the graph right there, the x-axis. How far up did I go? Went up 3. How far down did I go? Down 3. That's what the 3 does. That's what amplitude does. Again, the negative just reflected the graph across the x. It flipped it. Okay. The period. The period is almost always 2 pi. We talked about that earlier. The period for sine and cosine is 2 pi. But if they put a number in front of the x or the t, what's going to happen is it's going to be a horizontal shrink or stretch, which means it's going to change the period. The period is basically the horizontal stretch or shrink. All right, so 2 pi divided by b. Look where b is. You take the number in front of your x, divide up 2 pi by that number, and that's going to give you your new period, or how far your graph goes. Period means how far your graph goes before you start repeating the same shape again. Okay, now I got a couple to show you here. It says find the amplitude and the period of each function in the sketches graph. Okay, let's do this first one. First of all, the amplitude is the number in the front, it's 4. The period, you do 2 pi divided by the number in front of the x, 2 pi divided by 3. So when I start drawing my graph of this cosine, still going to go well, this time I got to go all the way up to 4 because that's the amplitude, all the way down to -4, that's the amplitude. Now this time on my 4 slashes on my x-axis, I'm not going to go all the way to 2 pi. The period starts over 2 pi over 3, so my 4 slash is 2 pi over 3. Halfway to 2 pi over 3 is 1 pi over 3. And because it's a positive 4, I'm going to start up here, go down, down, up, just like that. Those are my 4 dots I'm connecting, so connect the dots, la la. There's your basic cosine graph, and it starts repeating itself again. Okay, so the difference in the graph is what goes on your axis, x-axis, and your y-axis. The key to your test this Friday is going to be labeling your axes correctly. You got to label them. That's the only way I'll know if you know what you're doing. All right, so one more, and we are done for the day on the video. This one, amplitude is 2, number in the front. The period, you would do 2 pi divided by whatever's in front of your x, which is 1/2. If you do keep, change, flip right there, you get 4 pi. That's your period. So I'm going to draw my graph. The amplitude is 2. So you're going to go up 2 and down 2 from your x-axis. I'm going 4 slashes like always. The difference is now your period's 4 pi. That's your 4th slash. That's when it starts repeating itself after every 4 pi. Halfway there is 2 pi. You could also go backwards this way. You know, you could go all that. Now, it's sine. Don't forget what sine does. Sine usually starts at 0, starts here, and then it goes, you know, it goes up, down. It goes like that, up, down, up. But because there's a negative front, it's been flipped. Okay, so instead of it going up, it's going to go down, up, down. So it's going to start here, all the way down to -2, back up to +2, and then back down there. It would do the same thing going the other way. It'd start going up and then start going back down. So the sine graph does this in the problem. Okay, and it keeps going past there. But that's right there is one period, one cycle of that graph. You could keep going the other side, it would do that. But this part right here, I'm kind of making it darker and darker. That is the main sine graph. And again, it's all about how well you label your axis. You have to label your x and y axis with your amplitude and your period. Again, amplitude, basically your vertical stretch or shrink. your period, basically your horizontal stretch or shrink. All right, just trig words. So we'll work on it tomorrow like we always do. Look forward to seeing you. Adios.